Hello. What's poppin', my peeps? Acids and bases number 4. I didn't tell you Monica wasn't here. Oh, wait. Oh, I just told you Monica wasn't here. I feel lonely. What can I say? Recognizing acids and bases, can you see the chemical and tell me what what it is? And what is its properties? Acids and bases, neutral salts, properties of acids and bases. So here we go. Characteristic properties of acids are, I shall list them for you. They are, first of all, they always produce this H plus ion in solution in their formulas. So they react with water to make H3O plus ions or H plus ions. Notice I put them both in there. They mean the same thing. I need to impress that upon you. They mean the same thing. H plus and H3O plus mean the same thing. And then they do have a list of properties. So they are tart tasting or sour. Many foods have acids in them. Vinegar is acetic acid. Okay, is acetic acid on our list? No, it's not. Okay, but vinegar is acetic acid. Okay, it's 5%, I believe, acetic acid. Stings in your eyes or in cuts like lemon juice. Lemon juice is citric acid. And then we have nitric acid on there, not citric acid. So that's not a common acid for us. But lemon juice is also an acid. Very good for cleaning things like coffee pots, both vinegar and lemon juice. They do react vigorously with metals to produce a hydrogen gas. We will look at a whole different video for the reactivity series to understand that reference table, but they do react vigorously with metals. They are, of course, electrolytes, but both are acids and bases. But let's put it in there. They are electrolytes. They produce dissociated ions in solution, or in other words, they dissociate. Verb. They turn litmus paper red. Okay, litmus turns red in acid. Okay, I think that's it. One more. Oh, it does look a little bit like pure water. It's clear and colorless. Acids are harder to tell. If I pull out a few acids from the back room, they're going to just look clear. You won't even know until you maybe smell some of them. And all of a sudden you'll be like, whoa, that sulfuric acid is, whoa, it's very smelly. Yeah, because it's going to try to, do its acid thing. Okay. Characteristic properties of bases. Well, first off, they form OH minuses in solution either directly or indirectly. Okay, how's that? Put both of them together, our theories. These are bitter, so dark chocolate is a little bit basic. Okay, it's bitter. Reacts with skin oils to produce this slippery feel. Bases are very slippery, and it almost doesn't feel like it goes away. Okay. Soaps are very basic. This is a part of how they clean oil and grease off so well. And we use lye to make soap. You use a very strong base and a fat to make a soap. And you'll learn about this reaction in organic. It's called saponification. There, I threw a little foreshadowing. Throw you a little bone. Okay, they are, of course, electrolytes. They produce ions in solution, so therefore they will conduct electricity. Bases are also electrolytes. And they will turn litmus paper blue. Bases turn it blue. One way to remember, B and B, bases turn it blue. And they're also bitter. Okay, they also look like pure water. Sometimes they have a little bit of a tinge, though. Sometimes they'll get a little yellow, or when you see the heat rippling off the pavement, you see the air kind of do that. Sometimes those solutions will do that, and they'll have that little ripple in the actual liquid. And it doesn't look as clear, as perfect as an acid does, but it could. Okay, and these do not react with metals at all. What I did not put on for both of them is that they are caustic. Technically, acids and bases are both caustic. We'll see who puts that on your paper with a circle. Maybe you'll get some extra points. Caustic, Caustic. And all that means is it will burn you. Acids are caustic and bases are caustic if they are strong enough. In this case, if they are in high enough concentration. Okay. Characteristic properties of salts. This is just any ionic solid. They are a product of a neutralization reaction with an acid and a base. Yes. They do not produce any acid in ions in solution. They do not produce any basic ions in solution. They just neutral salts. There's no Na or OH. Nomenclature, how do I name these things? So real quick, and you're only going to ever get asked the ones on here, so you can look them up, but there is a trick to naming them. The spectator ion is the root. And then it's going to end with ic acid. So let's check one out. I have an HCl. So hydrogen is, we go at hydro, we do the root, right? We use the root of hydrogen, which is hydro. And then we add in chlorine and ic acid, we get hydrochloric acid. Beautiful. Isn't that nice how that works? And now let's do a base. So we're going to name the metal and then just end it with hydroxide. This one's really easy, except for ammonia, of course. So NaOH becomes a sodium, and then we add in that hydroxide, and it just becomes sodium hydroxide. Super easy. Okay, good. And now you kind of get a feel for the naming structure. The names are all given for you already. So there you go. Look them up. Here's your tables. That's it. There you go. 4 videos and we out. Peace out, bean sprout. Now, if I can find that button, I can turn off the video.